All right, so we're going to do a little more on trig functions here. One of the things we need to know is this, that a lot of functions in trig are what we call cofunctions. And this is what that means, is that, and we'll do this in degrees first, but if I have the sine of some angle, theta, I'm going to get the same value if I use the cosine of 90 minus theta. That's if we're in degrees. And obviously, if we're in radians, then the sine of theta is going to be equal to the cosine of pi over 2 minus theta. All right, so that's what these two, sine and cosine, are what we call cofunctions. And similarly, the tangent of theta is equal to the cotangent of 90, these should be degrees, 90 degrees minus theta, right? Or in, of course, in radians, it's the cotangent of pi over 2 minus theta. So it doesn't matter whether we're in degrees or radians, the idea is the same. And it also works for secant and cosecant, right? So the secant of theta is equal to the cosecant of 90 minus theta. And similarly, in radians, the secant of theta is equal to the cosecant of pi over 2 minus theta. And this works both ways, right? So the cosine of theta is equal to the sine of 90 minus theta. Right? That's always the case, and that works for all of these, right? We can go backwards. And let's just look at this example of that. Suppose I have the sine of pi over 6, right? Well, the sine of pi over 6 is 1/2. We know that. And then if we want the cosine of pi over 2 minus pi over 6, well, let's see, that would be the cosine of 3 pi over 6 minus pi over 6, which is the cosine of 2 pi over 6, which reduces to the cosine of pi over 3, which we know is 1/2, right? So, and we could have done that in degrees, the same thing. We're going to get the same value there. And I used one that we know, but it doesn't matter if we know it or not, right? It could be, let's just say I have the sine of, let's do 17 degrees, right? And let's look and see what that's equal to. Let's bring up our handy dandy calculator here. Let's make that a little bigger. So that's supposed to be 17. So let's just make this just a little bigger so we can see what's going on here. Come on, give me a... All right, so we want the sine. Oh, better make sure I'm in degrees. I am, okay. So I want the sine of 17 degrees, and that's equal to 0.29. So sine degrees, that's weird. Oh yeah, the value. Okay, so now let's look at the cosine. The cosine of 90 minus 17, right? And so we should get the same thing, and we do, right? So that works for all of those kind of functions. All right. So where was I? So Right, so we did that on our calculator. We didn't need to write anything out here. Now what that leads me to is an equation like this. Suppose I have the sine of 12x plus 38, and that's equal to the cosine of negative 5x plus 24, and I need to know what are these angles. What is this angle? What is this angle? And let's do this in degrees, right? So I want what is theta in degrees here and theta in degrees here. Right? So if these two are equal, then this angle plus this angle has to be 90 degrees, right? Because we've already said that the sine of theta is equal to the cosine of 90 minus theta. So whatever theta is, this has to be 90 minus it. So if I add those two, so 12x plus 38 plus negative 5x plus 24, those two things have to be 90, because 90, and these are in degrees, because 90 degrees minus this has to equal this. And so I can just move it all over there. So that gives me 7x plus a whole bunch. What is that? 62 equal to 90. And so 7x is equal to 38? 28. Let's see. 28. 28. So x is equal to 4. So now I can find my two angles. So let's do 12 times 4 plus 38. And that's equal to, let's see, 48 plus 38 is 86. So this, right, if this is 86 degrees, this must be 4 degrees, right? And I can show that by saying negative 5 times 4 plus 24 equals, this is negative 20 plus 24 is 4. Right? These have to add to 90 if I did this correctly. So once I know what this one is, I know what this one is. All right, so that's not too tough. Let's try one more just to make sure we're on the same boat here. Suppose I have the secant of 7x plus 32 equal to the cosecant of 2x minus 14. Not 4, idiot. All right, we go 14. 2x minus 14. There we go. All right, so once again, these are, if this is my theta, and we'll do it in degrees, then this must be 90 degrees minus that theta. Yes? So these two added together have to be 90, so I get 7x plus 32 equal to, not equal to, plus 2x minus 14 has to equal 90. So once again, now I have 9x equal to 32 minus 14, 18. Why am I keeping the equal sign in there? I don't know. Plus, where was I? 18, right? Equal to 90. So 9x equals 72. And x is equal to 8. So plugging that into this first one, I get 7 times 8 plus 32. And that equals 88. So that means this must just be 2. Right? So this is 88 degrees, and this is 2 degrees. And we can do the same thing with radians if we wanted to. All right, so let's look at another type of equation thing here. And these are pretty simple. want you to think about it, but we're going to be doing some delta mass, and they have a little weird thing here, so I'm going to add that onto this. So suppose I have the sine of theta equal to the square root of 2 over 2, and I want this in degrees. I could do it in radians, but I want it in degrees this time. All right, so what I have to think about, well, I know this number. And so if I think about my unit circle, right, and I don't do very good at drawing these circles on there, but if I think about my unit circle, this is 45 degrees. Yes, 45 degrees. So one of my answers, theta, is 45 degrees. But this is the sine, and sine follows y. So where else is the sine positive square root of 2 over 2? Well, right over here, right? 45 degrees away from here, right? Because 45 degrees is my reference angle. So notice that if I draw kind of a horizontal line, I can get both of those, right? Because it's sine, they both go that way. So the other one is 180, theta is 180 minus 45 degrees, which is 135. All right, and I could do that in radians just as well, and we might do some here in a minute. But the key is that I have to draw these little lines in the delta math. They want these lines. So if I'm doing sine, I'm always going to be using a horizontal line, yes? Because even if I wanted negative square root of 2 over 2, if I want sine equals negative square root of 2 over 2, well, that means if I put that in my calculator, I'm going to get negative 45 degrees, right, is here, but I'm also going to have one over here, right? They're both going to be here because we're negative in both of those sites, so I'm going to have theta is going to be 180 plus 45, and theta is going to be 360 minus 45, right? So if I'm plus 45, I'm at 225, and if I'm minus 360, I'm at 315, right? And those are all degrees. I keep forgetting to put my little degree symbol there. All right, so in the delta math, they'll ask for whether it's a horizontal line or vertical line. And notice that if I did the cosine of the same thing, I say the cosine of theta is equal to square root of 2 over 2. Well, that's when I put that inverse cosine in there, right? Because that's what I'm going to have to do, right? So I do the inverse cosine of square root of 2 over 2. It's going to give me 45 degrees again. So that's my reference angle. But cosine, so here's my reference angle, 45 degrees. That's one of my answers. But cosine is positive also in the fourth quadrant. So I get a vertical line there, right, to match those up. So I'm going to have 45 for theta. And I'm also going to have theta equal to 360 minus 45, which we already know is 315. All right, so that's true for both of those. But now let's look at one that's a little different. Let's look at the tangent. The tangent of theta is equal to 1. All right, so where does that come in? Well, if I do the inverse tangent of 1, so if I do the inverse tangent, I'm going to get 45 degrees, right? So if we think about the unit circle, that's over here, right? 45 degrees, that's my reference angle, and so that's one of my answers, so that's theta right there. But where else is the tangent positive? Well, it's in the third quadrant, right? Because remember, the tangent is sine over cosine, right? So if both sine and cosine are negative, which they are in the fourth quadrant, I'm also going to be right there. So this is a diagonal line, right? And this is going to be 180 plus 45. So theta can also be 180 plus 45 degrees, right? Which is 225 degrees. All right, so we can get either one of those happening. And what if it was the tangent of theta equal to -1? Well, now when I do the inverse tangent, -1, I'm going to get -45 degrees. So now what's happened is I'm down here, right? And this is minus 45 degrees, right? But 45 degrees is my reference angle. So this is, theta is 360 minus 45, which we know is 315. These are all degrees. But also, I'm going to be in this quadrant, right? 45 degrees away from there, so it's going to be 180 minus 45 degrees, which is 135. All right, so we want to make sure that we're getting the right places. All right, so I was going to look at a delta math with an equation like this, right? So let's take a look at this equation, right? I'm going to write it down and then we'll do it. And so you can't see what I'm writing, but this is 5 times the tangent of theta plus 8 equals 4 times the tangent of theta plus 1. All right, so let's look at how to do that problem. All right, so there it is. So what I need to do is get the tangent of theta all by itself. So I'm going to subtract 4 tangent from both sides, and that leaves me the tangent of theta plus 8 equals 1. And then the tangent of theta is equal to -7. Now, obviously, this would not work for the sine or cosine because they have to be between 1 and -1, but the tangent can be any number. So now I want the inverse tangent of -7. So I'm going to bring up my calculator. Let me bring it over here. So I want the inverse tangent, so second tangent of -7, right? And I hit enter, and I get -81 point, and let's just round it to 2 decimal places, 87. All right, so that's my number, right? So inverse tangent is -81, so let's think about where that is. So that's down here, right? -81.87. So now what I'm going to have to do is my thetas then, and there's going to be 2 of them. Theta is going to be 360 minus 81.87, and my other theta is going to be over here, right, with this same reference angle of 81.87. So this is going to be 180 minus 81.87. So let's just bring up our calculator and do those 2 real quick. So, what did I say? 360 is 60 minus 81.87. And we enter that and we get 278.13. All right, so whoa, don't do that to me. Stop it. All right, so the first one then, and you can't see this obviously, is 278.13 because I got it covered up. There it is, 278.13. Oh my gosh, what have I done here? Let me get that out of there. Holy moly, I don't even know what I've done. Oh, how did I do that? I don't know. All right. So then the other one, sorry about that, is 180 minus 180 minus 81.87, which is 98.13. And so those are my two angles, right? And we can do that with any of our, whether it's sine or cosine or whatever. We just have to remember, where is tangent negative, right? Where's tangent? It's these two quadrants. If this was had been -8, then that would have been a +9, and we would have been in these two quadrants here, right? So that's the kind of thing we're going to be doing in class. All right, so hopefully we remember all our functions, right? I think we covered all of them before, but remember, we have sine, cosine, tangent, cosecant, secant, and cotangent. So, and we can have any of those kind of problems. All right, so I think that's it for this lesson. I hope to see you in class on Monday for another exciting adventure in mathematics.